in terms of statistics, do you think that there's a big gap amongst a lot of machine learning practitioners that don't study statistics? I think that there's a lot of value there. I mean, I'm kind of like, I have a lot of confirmation bias on this because I was a statistician before getting into machine learning. And so I like to always think that there's a lot of value in that. But I think in terms of understanding your data and especially cleaning up your data, it can be hugely valuable.
I mean, there's a lot of stuff that is in statistics and that I've learned in statistics that is just useless now. And it's a waste of time. Like it's quite a traditional field, and doesn't move very quickly, and people are still being taught stuff. Well, they definitely were then being taught stuff that is not really that useful. Like there should be much more emphasis on computational methods, I think. So, but having said that, I mean, there's a lot of stuff that you can just safely ignore in statistics, like the
P-values.
Yeah, p-values, like the delta method, like they've got quite a lot of like mathematically intensive stuff. You just don't really need any of that. But you do need the approach and the kind of attitude and the skepticism about data and really understanding like bias, really at your core understanding things, bias, selection bias and all that stuff. Like that's statistics has got a really, really, really important, has got really important lessons to learn about, to teach about that. That's really, really critical. Most of the other stuff, you don't really need any of the technique. Like the techniques, do you really need any of that stuff? Like you need to know linear regression. You could do a lot with linear regression. I don't think you really need much more. I don't know. That's a bit of a blanket statement, maybe.
I think something that for me has come in handy is actually, interestingly, for things like evaluating not statistical bias, but like unwanted bias. So your model's behaving in a way that, so for example, at our company at Nebula, we're doing a lot of things in human resources. And so, for example, we would be ranking people for a specific job description. We have a database of 180 million people in the US, and somebody puts in a job description, we rank everyone in the US for that role. We want to be sure that it's not ranking men better than women, for example. And so we have a test data set that we can test our algorithm on. And obviously, there's going to be some variation. There's the mean score on men is going to be somehow different from on women. You're never going to get exactly the same number. And so statistics has been useful for me there to be able to say, okay, but there's no statistically significant difference between these two groups. I don't know.
Yeah, no, absolutely. I think the concept of statistical noise is just a really deep concept, and it needs to be really, really understood. And I don't think it really, some of these basic concepts in statistics, they are just not that widely understood by people that come really from a computer science background. So, and also stuff to do with data visualization. Like I'm literally like today, we're showing someone how to make a normalized histogram. And it's quite typical that I'm teaching someone how to use a scatter plot. It's people who are really, really good. They've got a great background. They come from a computer science background. But they don't really know how to do relatively straightforward things in data analysis, like make a good scatter plot or make a good histogram or whatever. It's kind of boring, this stuff, but it's also really, really important.
Yeah.